me or record.
The indicator tells chemist whether a substance is acid or alkaline to obtain an idea of how acidic or alkaline a substance is. We use another indicator known as universal. Universal means the indicator which have more than one indicator that we get by the mixture or mixing of two or three indicators. Like here, the other indicator, the color shows by this indicator can be matched against a pH scale. So what is a pH scale? You know very well. It is just a scale here. You can say that starting from 0 to 14, and between them the neutral point is 7. So here below 7 it is acidic, and above 7 it is basic or alkaline. So this also not only indicate the color that you have here. Only if blue, you can say that that is alkaline. Red, it's mean acidic. But by the use of universal indicator, you gonna find the strength. Understand the word? If an acid is there, what is the strength of the acid? Because it show you a variety or range of color. Okay, so the color you will indicate by the using of this universal indicator. It will show you just like as you match the color with, like here 0, 1, 2, 3, 4, like this, and same like here 8, 9, 10. It's going on in this way. Now the pH scale was developed by the chemist called Soren. The pH scale runs from below 0 to 14 as I draw here. Okay, this chemist who develop, you can say that, or make the scale that is starting from 0 to 14. A substance with a pH of less than 7 is an acid. So you can see here less than 7, it's mean acid, or on the one with a pH of greater than 7 is alkaline. So if you go more towards the pH 7, it means that is alkaline. One with the pH 7, if you have pH 7, then what
Sir,
it means? Yes.
you will send the recording or no?
Yeah.
Yesterday did.
Okay, no problem. I will send that one, and this time it's also recording is going on. Don't worry. It's said to be
Okay.
neither acid nor alkaline. Okay, if it will be 7, it means it's neutral. What it mean? Neither acids or nor alkaline. This is neutral. Okay, water is the most common example of neutral substance. You know that when you see the water bottle, if you remember that in the class I showed you, you can check on the water bottle, it's written pH. Mostly it's almost near to 7, some point 6.8 or 5, or some point 7.1 or 2, like this. Or you can say that, yeah, so it's mostly neutral. Now figure 8.4 shows the universal indicator color range along with everyday substance with their particular pH value. What the things you use daily, it will going to tell you about their pH, and the colors range you can easily find out. So you can see here, it would be too dangerous to taste a liquid to find out if it was acidic. What it tells you, you can't take a risk to taste a liquid, or in the lab you just go and see, I want to going to check the chemical and I want to taste it. No, never ever. Even don't touch. Chemists use substances called indicators. You know very well about the indicator, yeah, which change color when they are added to acid or alkalines. As you add these colors in, or these solutions or these indicators in the substance, if it is acidic or alkaline, many indicators are dyes which have been extracted from natural resources such as litmus. So here it's going to tell you, some indicators tell you if a substance is acid or alkaline. Till here, my dear student, any question?
No, sir.
It's very easy. We already done in the last lessons. Okay. Now we move to the next page. Here you can see the pH scale actually. And the color range and the pH value from the scale you can easily find from here. Try to understand. Look, this strong acid, it's mean it's red. Look, this one. So you can see it's almost coming here. Okay. Even you can give number from here. 1, 2, sorry, 0, 1, 2, 3, 4, 5, 6, and 7. Now move next. 8, 9, 10, 11, 12, 13, and 14. So it's mean if this color will come like this, you need to remember, because when you have a strip or you have a color chart of pH like this scale, you can easily find out that is the color where 7 pH mean to say your solution is neutral, because that shows you it is 7 pH. Now, if you will get a color like this, it means strong acid, because 0 pH. Understand? And come towards the last here, the 14, this one, not go towards this one, till here, that indicate your solution is a highly acidic or alkaline, that is extreme. Now, I tell you, explain you both the ranges from most extreme acid to the most extreme alkaline or base. Between them, you have a range. Okay. And here it's also mentioned that what the things on the daily basis we have, what's their pH. For example, dilute hydrochloric acid. You know that what is this? Hydrochloric acid mean HCl. Okay. It's mentioned here dilute. You know the meaning of dilute. Yes or no? If you remember, I explain you about the concentrated and dilute solution. You remember or forget? Yes.
Can you give a quick recap or no?
Okay, no problem. I will show. It's like this. If you have 1 glass of milk and in 1 glass you add 3 glass of water, that is your dilute milk. Okay. But if you have pure milk, you didn't add a single drop of water, that is concentrated or pure, you can say that. So in the same way, if in an acid you add more water, that is a dilute acid. Okay.
Okay, understand.
Thank you very much. Now the next thing here, it's going to show you lemon juice. Lemon juice is also acidic. It's acid. It's showing you almost 2 and it's almost reddish in color. Now, when you go little bit down towards the neutral, I'd say why down? Because we are moving from strong acid towards the weaker one. So that's a reason like orange juice, vinegar, ethanoic acids. These all are the examples of weak acids. You need to remember them, okay? But it's not mean that you're going to drink them or you can use them every day. It will be, you can say that the usable things, but you need to use them properly, okay? Not every time. Then what happened? The acidity start in your stomach. What it's mean? You will feel burning, okay? Like a burning sensation will come to your esophagus and it start to make discomfort for you. Did ever happen with you? If you take lot of orange juices every day, did anyone observe this one? Or lemon juice, is this happen with
No,
you?
I feel it with only sugars.
Okay, because sometimes in this they also use these kinds of things. Okay, but when you come to words, them as a milk, it shows you 7. So it's mean milk is also little bit acidic, but it's very little. Almost you can say that 1 point, it's more than this the pH of 7 of the neutral one. Now come to words at neutral point. That is your water or salt solution. What is the meaning of salt solution? In which you have NaCl. Okay. What is salt? All the salts. Sodium chloride, like other potassium chloride, bromide. These all are the example of neutrals one. Now, little bit more than or the at the edge of this one you have blood. It means your blood is almost basic. little bit, you can say that. So slightly alkaline, it start like toothpaste that you use to clean your teeth. Why? Because there the saliva in your mouth, and this the basic will going to kill the bacteria. Okay, so if they have a combination, that is very important for you to know that our saliva is also the law mean to say that also every time in your mouth it need some basicity like the toothpaste, so they make it little bit alkaline. Now here it tells you the lime water, not a lemon water, it is a lime water. Its pH is 10. Now the bleach, washing soda, aqueous ammonia, these are the example of alkalis, or you can say that the bases. uh, Oven cleaner like dilutes sodium hydroxide. Yeah, look this one, NaOH. This is a sodium hydroxide. So here I write HCl at the extreme. Please focus in this equation. And here I write at the extreme of sodium hydroxide. What it mean? NaOH plus HCl. When these two chemical react with one another, what they form? They make NaCl plus H2O. That is a neutralization reaction. When acid react with strong base, they make sodium chloride. Mean to say this salt, my dear. Understand? And this water. So both are what? Both are neutral. This you understand or not?
Yes, and what is HU?
Where is HU? I did not write anywhere HU.
Beside the diluted hydrochloric.
Here this is H2, H2O water, NaCl, this NaOH, HCl.
Okay, sir.
Okay, now move next. Hope you understand very well about the pH scale. Now, using universal indicator allow us to determine how concentrated one acid solution is compared to another. You can see from here. The redder the color, the more acidic the solution is. Solution which are very acidic contain higher concentration of hydrogen ion, mean to say H positive ion. You know very well about this. I
Sir,
explain. Yes, please.
can you write the equation again? I didn't write it.
No problem. NaOH, this is sodium hydroxide, strong base or alkali, plus HCl, hydrochloric acid. I don't have a space, that's the reason I'm gonna write. So this bond is broken from here. This sodium will going to join with chlorine like this, and what they make? NaCl. This is a salt, and this H hydrogen from here combine with water, sorry, hydroxide, and make water, H2O. Is it okay?
Yes, wait a minute.
Okay, no problem, take your time. Now, so you all know about this H positive ion, yeah, hydrogen ion. Another way in which the pH of a substance can be measured is by using pH meter. That is a new thing for you, and it is you can say that the most valid thing and easiest way to find out, and you can say that the most accurate one to use a pH meter. Understand? Now what this meter do? You can see here in the diagram below 8.5, it's written that another way in which pH of a substance can be measured by using the pH meter. Look, my dear, what is in it? That is just like a meter which is connected with an electrode. That one is an electrode, and here there is a small bulb. Inshallah, you will see this in your lab, in your chemistry lab easily. Okay, what you do, you simply dip this rod, this electrode in the solution, which pH you want to know. And here you can read the reading. It will show in the digits. Very easy, very simple. The pH electrode is placed into the solution and pH reading is given on the digital display. It is the simplest way to find out the pH of any solution. Now, till here, any question?
No, sir.
Okay. Now, look this part, the Bronsted-Lowry theory, what they two told you about an acid and a base. Now, let's see and going to learn about them. This theory defined as acid is an H positive ion, or you can say that proton donor. Why we call this proton? Ahmad Musab and Amro, you both know, because I explained this, I think, in second lecture. Yeah. H positive ion, why we call this as proton? Hurry up. Or you need, I explain them again. Yes, please.
Explain.
Yes, every time. Explain, explain. You will not going to reply me. And Mr. Amro, you same. Look, my dear, see here, that is the electronic configuration of hydrogen atom. Okay, this is the outermost shell of hydrogen. Inside the hydrogen, there is a nucleus. Okay, you remember that, and hopefully you know that hydrogen has only one proton in its nucleus and one electron around it. So P mean to say number of proton is equal to number of electron. It's mean one proton that is equal to one electron. Till here, any question?
No.
Okay. Now look what happened. When this hydrogen atom lose this electron, then what happened? Number of electron decrease and number of protons same. It's mean this no electron here. So my dear students, this take only or remain only one proton in this hydrogen atom. So we can say that this H positive ion is also, we can say that as a proton. Understand?
Yes. As
Because
a proton donor. Yes.
no, it's only a proton, because there is electron, he lose the electron. After that, the nucleus is remaining in the hydrogen atom. So we call this as H positive ion or proton.
Okay.
Okay, thank you. Now go back to the textbook. Okay. Okay, so an acid is an H positive ion or proton donor. Any substance that donate H positive ion, we call this as proton donor. Now, what is the base who receive this H positive ion, or you can say that the acceptor of H positive ion, we name this as base. For example, you have a book and I want a book from you. So you donate the book and I am the acceptor. Okay, like the same, when somebody want blood, so the donor go to the hospital and gave him blood, donate his blood, and the acceptor may be in the operation theater or on the bed, he received the blood, okay, or accept the blood. Understand? Now the key word here you should remember in your mind, acids are proton donor and bases are proton acceptors. Easy, my dear?
Yes.
Okay, now let's see the theory explain why a pure acid behave differently from its aqueous solution. Since for an acid to behave as an H positive ion donor, it must have another substance present to accept the H positive ion. It's not going to tell you the acid is only a substance that donate. Okay, for example, I want to donate blood. My dear, there should be a person who should be accept my blood. Yeah. So it's mean you need both the things. Then you can find what is an acid and what is a base. So if you donate something, there should be an acceptor. Okay. So the water in the aqueous acid solution is behave as Bronsted-Lowry base and accepting H positive ion. Look, HA. A represent here any acid. And this have H positive or H ion. Or you can say that in simple word, proton. When you dissolve this in water, water behave here like a base. Understand?
Yes.
Then this H or proton is separate, or you can say that dissociate from the acid and it go towards the water, and from H2 to it become H3, and here it gain positive charge and your acid will separate it in the aqueous solution. So if a substance can behave
Wait,
both,
sir, can you repeat?
yes, why not? Come here, come on the board. Look, this one. He just explained that this hydrogen as a proton, it's attached with an acid. And here you have a base like water, H2O. This, when you dissolve this acid in water, this H positive ion move towards the water and then it look like H3O positive. Okay, because the number of hydrogen increase, that's the reason it gain positive charge and this A become here separate out. So this is an acid and this is a base that going to accept this one. Okay, my dear. Now you can see that the acid donates, as we learned from the definition of Lowry-Bronsted. What it tells you, this donates H positive ion or hydrogen ion. Yeah, you can say that proton. And this water molecule act as a base. Why? Because it accept the proton. So this, the remaining part in front of you. Now, clear?
Yes, sir.
Okay, well done. Any confusion, please tell me, don't hesitate, because we have lot of time. We will learn, we will understand each and everything. Don't hesitate, okay? Okay, now let's move next from here to the example. My dear student, this is a very important part of the lesson and 1 mark question every time they ask from here. The word is amphoteric. Don't forget, I underline, you also highlight this word. What is the meaning of amphoteric? He can ask you by giving a statement and down he can write 4 options, multiple choices. Okay, so MCQ he can give you, or maybe he can give you in the fill in the blank, or can ask a short question for you. Okay, so what is the amphoteric? Do you have any idea?
No.
Okay, listen. If a substance behave both as proton acceptor as a base and proton donor as an acid, then it is called amphoteric. Very easy. If I say, okay, take blood from me and also give blood to me, or take 100 real from me and give 100 real to me, what it's mean? It's going to tell you, you behave like a both ways. Like you can say that some cars you can drive them on fuel, on you can say that benzene like petrol, and they also work on battery, on electrical cars like the Tesla. Okay, but if you can drive your car on both, like on benzene and as well as on the battery on electricity, then it is called hybrid. They show both character. In the same way, if a substance behave like the both thing, like acid as well as base, then we call them amphoteric. Easy?
Yes, alhamdulillah.
Alhamdulillah. Now you need to learn their examples. For example, aluminium oxide, that is behaving acid as well as base. Why we call this acid or base? Because when you're going to dissolve this, it also donate proton and also accept proton. Like the same way zinc oxide, it also behave in the same way. Now, after you can say that almost less than 1 minute is going on, so I will send you another link, okay?